Hello everyone. In this video, I'm going to focus on Excel and how to do linear regression, starting with the LINEST function, then looking at how to use slope and intercept to solve for the individual components themselves, and then finally how you can do this by individual pieces. Now you might wonder, why am I doing this video? Well, I actually have a video where I recorded doing linear regression with a bunch of systems, such as R, Python, Julia, SAS, and even Excel. But this has led to some confusion for a project that my students are doing, because this video actually predated when I created this project for the class. So therefore, when I did it, I had my X and Y that I just kind of chose randomly while using the Old Faithful data set. So looking at the computer here, we have the LINEST function, which you can see is for when we want to do linear regression. And then if we go down here to our syntax, we have LINEST, known y's, comma, known x's, and then we're not doing any sort of constants or anything like that. So this is just simple linear regression. We have one set of x values, one set of y values. So then looking at this, considering our linear regression, we have that y hat equals mx plus b, where we need to figure out what the slope is of our line, and we need to figure out what the intercept is. So if we were doing this by hand, we were finding the slope using the formula, we would need to solve for m equals n, which is our number of data points, times the sum of x times y minus the sum of x times the sum of y, all divided by n times the sum of the x's squared minus the sum of the x's, and then squaring that sum. So if we were to do this by hand, well, if we look at our Old Faithful data set, you'll see that we have 272 different values. So we have 272 different data points, which means that if we were to do this by hand, this would be tremendously tedious to do. So how can we do this in the easiest way possible? Well, the way we're going to do this is we're going to be using the LINEST command. So we're going to use equals, capital LINEST, parentheses, and we're going to select our y values, comma, then we're going to select our x values in parentheses, and that will give us our linear regression. And it's going to give us first our slope and then our intercept. So let's do that now. So we have equals LINEST, and then I'm going to select my y value. So I'm going to select the first y value. I'm going to go down to the very bottom, and then I'm going to shift click to select my y values. And then just to make things easier, I'm going to do comma, and then I know that the next column is B, so I'm going to put B2 colon B273. So there's 272 data points, but of course the first row is for the titles. So running this, you'll see that I have a slope of 0.075628 and a y-intercept of negative 1.87402. Now, what if you're not really sure about this and you don't really trust using this command or how to interpret it? Well, what you could do instead is you could use the slope and the intercept formulas. So in Excel, you can use slope, all caps, again, parentheses, your y values, comma, your x values. So let's say we did that. So we have our m here, this will be our slope. So we do equals slope, and then we select our y values, which were A2 through A273, comma, and then we do our x values, B2 through B273, in parentheses, and we get 0.075628, just like our LINEST told us. If we wanted to do our intercept, right, so looking here, the syntax is you put equals to run a command, and then it's going to be intercept, known y's, known x's. So again, this is going to be equals intercept. I'm going to put my y values, A2 through A273, comma, B2 colon B273 in parentheses, and you'll see that we get the same intercept. So you could solve it just using LINEST, or you could solve it using the slope command and the intercept command. If you're not really sure about any of this and you actually want to solve it using our equation, looking at our equation, we have that m equals n, which is the number of data points we have, in this case 272, times the sum of x times y minus the sum of my x's times the sum of my y's, divided by n times the sum of my x's squared minus the sum of the x's, and then this whole thing squared. Now, in order to solve this, we already have the sum of x's and the sum of y's. That's our initial data. What we need is we need the sum of our x times y, and we need the sum of our x's squared. So the next thing I'm going to do is I'm going to create a column called xy, where it is just going to be equal to, and I'm going to take my first value, in this case my y value, so a2 times, and then my x value. Plug this in, and we will get x times y. I'm then going to go to the bottom right corner. I will drag this to get all of the x times y values. Next, what I'm going to do is I'm going to get my x values squared. So doing this, my x values, going back to our data, we have that x are the weighting values. So I'm going to select weighting. So the first value is going to be 79, and then I'm going to square that. Again, I'm going to select that cell. I will drag it all the way down so that I do this for all of my x values. I will square all of them. Okay, so now in order to solve this though, we're going to figure out what are the sum of our x's, our y's, our x times y, and our x squareds. So in order to do this, we're going to do equals, and this is going to be capital SUM for sum, open parentheses, and then I need to select my values. So in this case, my values were my weighting times, which means that it's going to be from B2 to B273. And then I'm going to do the same thing for my y values. It's going to equal to sum, open parentheses. In this case, it's my A column, so it'd be A2 through A273. Next, I'm going to do the sum of my x, y values. This is going to be equals to sum, and that's going to be my C column, so C2 through C273. And then I'm going to find the sum of my x squared values, which is going to be my D columns. It's going to be equals to sum, and then D2 through D273. Okay, now that I have all these values, I can quickly figure out what is the slope of my linear regression. So first thing I'm going to do equals to, and I'm going to go up into my actual editor here so that I can kind of set it up. So I'm going to put open parentheses, close parentheses, divided by open, close parentheses. So I'm setting it up so that I've got my top terms and my bottom terms. Now, our first part of the numerator is going to be n times the sum of x, y. So this is going to be n, which you could do another command to get the length, but in this case, we know it's 272 data points, times. Now I'm going to take the sum of my x, y values, which is this one right here, f8. And then I'm going to subtract the sum of my x values, which is f6, times the sum of my y values, which is f7. And that is it for the top. Next, I will select down in the bottom. Now, in this case, I want to take my n again, so 272 times. If we look at our equation, this is going to be the sum of my x squareds. So that is going to be this cell right here, sum of my x's squared. And then I'm going to subtract the sum of my x's, and then I'm going to square that. So if I go to my sum of my x's again, I'm going to select this cell, and then I'm going to square this term. And doing that, you'll see that we got the same intercept that we had gotten previously of 0.075628. From there, if we wanted to figure out what the intercept is, we can use this. B equals y bar minus m x bar. Well, we have m, now we're going to need y bar and x bar. Now the way we find y bar, so we did here, right? We have y bar, this is going to be equal to, equals average, open parentheses, and now we select our y values, which in this case was our eruptions. So this is going to be A2 through A273. Next, I'm going to get what my x bar is. So this is going to be the same thing, equals the sum, average of, now it's going to be my B column. So B2 through B273. And then the last thing is to get my B, this is going to be y bar, so equals y bar minus m times x bar. And you'll see that we get the exact same value as when we solved it using LINEST and using the slope and the intercept commands of a b or y-intercept of negative 1.87402. I hope this has been helpful to help you all kind of learn how to use Excel for things like our project using linear regression. If you're interested in knowing more how to use things like R, Python, Julia, SAS, MATLAB, and a bunch of other tools, I actually have a video that you can watch right here.